Yellow, 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 everybody. Hopefully, you guys can hear me. Just making sure here. 1 second. Okay, yeah, you guys can hear me, right? Cool, cool, cool. Please give me a thumbs up if you can hear me and if you want me to make any changes. So, today is our day three of developing basically creating a AI influencer. I created a nice little thumbnail using the Ghibli art with some nice prompts. Let me know if you guys like this one. I'm creating more I think I created the day four one as well with a similar retro theme in the back and like just me being on a computer. So hopefully you guys like it. Some interesting stuff want to show you. And with that being said, let's get into our Udacity course. Udacity, I think that's how you spell it. Perceptron algorithm we were talking about right yesterday, where we had like some of the code, some test run, and like we had to do it. So let's get that done first. I'll be going over step by step, so you will learn some Python and stuff. But along with that, right, you will be, I'll make sure, right? Okay, everything is good. So along with that, we'll do nonlinear regions, error functions, long loss error function, discrete and continuous. So I think we will be able to cover five more topics today, just like yesterday, and keep doing five, 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 five at least for some time, unless until we get like a big break and then we just go rumble. So with that being said, let's get going on our perceptron one, right? So basically, in this coding, the perceptron algorithm, right? We had the basic equation, weight. We had the initial weight. We change it with alpha and like our percentage, right? So that's how we have to do. Let's lo watch the video again so we can just start doing it.
Now we finally have all the tools for describing the perceptron algorithm. We start with a random equation which will determine some line and two regions, the positive and the negative region. Now we'll move this line around to get a better and better fit. So we ask all the points how they're doing. The 4 correctly classified points say I'm good, and the 2 incorrectly classified points say come closer. So let's listen to the point in the right and apply the trick to make the line closer to this point. So
Remember basically, let's say the positive one that's in negative, right? Versus the negative one in the positive. We have to plus minus things, right?
here it is. Now this point is good. Now let's listen to the point in the left. The point says come closer. We apply the trick and now the line goes closer to it. And it actually goes over it, classifying it correctly. Now every point is correctly classified and happy. So let's actually write the pseudocode for this perceptron algorithm. We start with random weights w1 up to wn and b. This gives us the equation wx plus b, the line, and the positive and negative areas. Now for every misclassified point with coordinates x1 up to xn, we do the following. If the prediction was 0, which means the point is a positive point in the negative area, then we'll update the weights as follows. For I equals 1 to n, we change wi to wi plus alpha times xi, where alpha is the learning rate. In this case, we're using 0.1. Sometimes we'll use 0.01, etc. It depends. Then we also change the bias unit to b plus alpha. That moves the line closer to the misclassified point. Now if the prediction was 1, which means the point is a negative point in the positive area, then we'll update the weights in a similar way, except we subtract instead of adding. This means
So basically, when the point is plus, you add, point is negative, you subtract. Given the fact, the negative is in the positive area, but the point we are talking about is the negative point, so negative.
for I equals 1,
Easy to
change
remember.
wi to wi minus alpha xi, and change the bias unit b to b minus alpha. And now the line moves closer to our misclassified point. And now we just repeat this step until we get no errors, or until we have a number of errors that is small. Or simply we can just say, do this step 1,000 times and stop. We'll see what are our options later in the class. Now we
Cool. One thing I just want to check. Okay, just want to make sure no messages. Cool. So we have the algorithm, right? Like basically the pseudocode of the algorithm. Let's get started with writing it down. Coding the perceptron one, there is step, blah blah blah. So here I'll just use my Visual Studio Code because I just like that. Mhm. We have numpy runtime dot random seed 42. Setting the random seed feels free to change it and see different solutions. So I don't know how random seed works, honestly. But we have step function. If t is greater than equal to 0, return 1, else 0, right? Prediction based on the step function. Our code will go here, step, right? So simply if I put, um, let's find based on our information, x and y, w, b, okay. Fill in the code below to implement the perceptron trick. The function should receive as inputs data x and y, the weight w as an array, and the bias b. W is an array, okay. Update the weights and bias W P according to the perceptron algorithm. So how we do it is if the prediction was 1, we need to decrease the weight. And here, this is nice though. GitHub Copilot is pretty good in this case, I guess, with the comments. So we know like the prediction was 1, basically it was set to be positive, but it technically was negative. So how we do if learn rate is 0.01, okay. If first let's say calculate train perceptron algorithm, there's this y max min boundary. Okay, where's perceptron step called? Okay, so first we calculate the integer. Actually, prediction. No, it was the perceptron step was called here. It goes here. It calculates the whole thing. Prediction. We send the info. So let me just just quit. Okay, all good. So I had this prediction, this with the weight X matmul. I have no idea what that is. So what I'll do is we have Python here. Python 3 is there, right? So pip install, or pip3 install numpy. Installing, so we will be able to get all those information. I need to see what matmul does. NumPy matmul function implements. Okay, array like input arrays scalars are not allowed. Okay, what is it saying more? Sorry, I'm just making sure my stream has paused on my phone. You guys can see me. You guys can see me, right? Can you give me a thumbs up if you can see me? It says connection lost here on the phone. Hey, stream manager. Okay, yeah. Okay. See. So, NumPy, we have X here, matmul X and Y, and we were able to successfully download it. That's good. We have this function, X and W with the capital X. So X is basically the array of those, and W is the weights. Okay. Y is like the Y function itself. Okay. It paused for you. Now is it good? Is it good now? It froze for me. I don't know why too. Like it should be working. Can you guys see me? Like you can see if I'm changing the screens. You guys can see me. Eh. No? Still the issues there? Can anybody else see it? Okay, it's good now. Okay, okay. Thank you. Thanks, Panda, for making noticing that. Okay, so now we have two x1 and x2 are array, right, in this function. And what matrix product of two arrays. So basically we are given two arrays and we are getting the matrix multiplication like which I showed you yesterday, if you remember. Here, this one, remember? Matrix multiplication should be like n times 1, 1 times n, and the middle one goes away, so it becomes either n times n. We want 1 times n. Benjamin, your video seems fine to me. What's an issue? Okay, yeah, so that was like frozen for some time. Now it's good. Even for like my phone, it was frozen. So that was the issue. But thank you for mentioning. It's back to normal. Awesome. Thank you, lads. So we are working on this, right, function, and we good, right? Yeah. So we are working on this function, and we have like two matrices X and Y. xt max t 0. Okay. So it's training the algorithm, right? This function runs the perceptron algorithm repeatedly on database, returns a few of the boundary lies obtained in the iteration. Okay. And it's calling this step for each epoch. In each epoch, we apply the perceptron step. What step is that? Is to find the y cap. So what we are doing with the prediction is we have to send x, y, and b, the bias, right? We send this, right? What is this code by this? Okay, let's see. I have GitHub Copilot. I have registered. So for I in range length, this step function is returning zeros and ones. So it doesn't make sense to have that, right? Then we have if get this is prediction is one, right? And y, which should be correct or not. What is y? Where is y getting calculated? Y train perceptron. Let's say the y is like the value, whether it was or not. So y is basically the step value we got from our algorithm, right? What is it? I'm actually confused. One second, let's recall the perceptron step works as follow. For a point PQ, label y, and the prediction given is y cap step function of w1 x1 plus w2 x2 plus bias. If the point is correctly classified, do nothing. If the point is classified positive, but it was a negative label, subtract. If the point is classified as negative, but it is a positive one, right? Do this. Okay. So label, what was the label? Why is the label? And if label, which is like the negative label, 0, positive label 1. Click on test run and blah blah blah. Okay. So with that being said, what we'll do, why is the label? So if prediction is 0, prediction is 1, which is the point is prediction was 1 and label was 0, we decrease the weight, right? With the learning rate. So whatever is the learning rate for every W, we are reducing it with the X, and I think it will do the matrix multiplication. I don't know. And we are doing the same with the bias. Else, else if this is the second condition, right? Here. I like this Copilot. It's not that bad. But like I think Gemini is winning, right? The AI race for coding, Gemini 2.5. The company I work for, they love Gemini there. So and one loves Copilot. So and it was nothing, and if there is nothing, do nothing, right? Return WB. So I think that does our algorithm. Is if the prediction was one, but the label was negative, right? We decrease. Basically, the point was supposed to be a negative point, but it says it's positive. Versus if the point was supposed to be a positive, but says it's negative. I think let's put this into, and I will post this code on my GitHub, so hopefully you guys can check it if you want to learn, do some learning. Okay, run test. Okay, awesome. We got some error. Line WI perceptron, line 34. What was it looking for? I believe it's because of this. Let's see. Okay, so what we have to do is I in range length of x X is equal to this, right? We are changing every X. Oh, we don't change every X actually. We change the weight. Weight of I is equal to weight of X, whatever is X, then the learn rate, right? For every week. So we don't do this. This is like not optimized code, but gets the job done. Or wait here. And here it should be positive because the prediction was 0, but it's a positive. It should be positive. Okay, this should be good. I think this does the job, right? Run test. Do you guys see anything issue? Okay, hard to understand with this. File workspace, whatever, line 34 in import file. File line 23. Oh, not and. Wait, that and works in Python. It doesn't? Operators base and. The and works like that. So this is good. What else is saying? It's supposed to be something else. Okay. I think we have to go through properly in this case. Okay, what is saying? Line 34 in module file this. Line 2 in this. Line 107. 51. Okay. I can do file. Where's the wrap one? View word wrap. Okay. In the perceptron, this one, this one, this one. Okay. So we have line 34 in the main.py, and our main is this and this, and per if one value array, the truth value of an array with more than one element is MPQS. Oh, I see, I see, I see. So what is going on is XW 0 saying. So if I just run this one, so it's sending me multiple information, multiple like values, not just one or zero, it's sending like multiple. Hmm. I have to go one by one. For each prediction, if the prediction was one, do this. So for each prediction, I have to go X and W. Hmm. And I want to see what exactly this one. There's one array here, second array here, matmul function. Okay, let's see. Matfield function returns the matrix product of two array. Okay, it's going to return an array. Okay. While it returns a normal product of 2D array, if the directions are either greater than 2, it is okay. So it's going to return me a array. That's my mistake. So it will return an array, the predictions, and I have y, which should be an array itself as well, right? So I have to, for every array, this, for I in range of this array, get prediction, I, even I can do, and this will be wi, and this will be I as well. If this is get prediction is the weight. If the weight is doing this, no, I think I'm doing it wrong. Think about it. I'm getting the array of predictions. I have the array of values. So first, let's say take one by one. I'm taking one prediction, the first one, the first one. Stop sending me. So first one, if the labeling was wrong, labeling was wrong. Every go to every single array in X and do changing in the weight by this much. Then go back and get the new predictions. Does it work? Is the predictions right? Okay. I think I can do it this way. For I, uh, till all the predictions are yes, do this. If not, go back. Hmm. So, don't have to draw, actually, just have to think. I just have to go back and get the new prediction and then repeat. Okay, so here it will be like this, right? Decrease, but keep decreasing till the prediction is correct. So probably I will get like a new um, array. So prediction was wrong. I decreased the weights and bias. Now, yeah, now I check. Correct. So now if to check if the prediction is correct, right? Yes, Bruno. Mhm. Sorry, there's a dog here. Um, for every weight, reduce this, including the bias. Get prediction. So prediction for just this one. So I just want What will be the best way, that's like if I want to get just one prediction back? You think I can get one prediction back? I should be able. And I doesn't change. We need correct prediction. What is the prediction here? Hmm, get just the prediction for this one, but it will change this. So get prediction. So maybe I'll create a flag assuming all predictions are true or correct. Assuming all predictions are correct. Do this. And yes, if the prediction becomes false, prediction becomes false. Do how is do while loop in Python? Mm-hmm. Instead of do while number, this it becomes false. It keeps going for all the predictions, but the flag is already false. Yeah, think about it. I'm thinking so if the prediction there's no do while in Python, but what I can do with do while? This while and see. Okay, if the flag becomes false even once, we need to restart the whole loop of perceptron algorithm, right? The step. So how we doing it is we have an array of x, an array of y. This will be like weights and so this will be weights. This will be coordinates. We get a we get and how is the data? So we get x and y. We get so many points. X, y, and bias, right? Now we have to. No, sorry. We're getting x. So w or there's this one. So solution. There's w. There is x, and there is the y cap. The y cap is basically its label. This is the label. This is the I think it's where it is x and y. Or weight. We are getting the weight for each point. Okay, let's see. Separate the following. Given in the file data.csv, right? Recall the procedure. Click test to graph the solution of the processor gives you. Draw. It's actually draw a line set of dotted lines that show how the algorithm approaches the best given by the black cell line. So we are drawing a line. We have x and y coordinates and the label, whether it is labeled correctly or not. Yes. If it is not, then we are changing by little. Let's get that. So get prediction array. We're getting the whole array of predictions, right? Whether it was right, wrong, whatever for all these x values and y's. We get x, y learn rate, number of epoch, x minimum, and x maximum is zero. This y minimum, y maximum, NP array is random, one or two. Bias is random, x max. Okay. Fill in the code below to implement the preceptor. The function receives an input as inputs the data x and labels y, weight as an array, and the bias. Update the weights and bias according to the preceptor algorithm. So maybe for every we don't, and the whole algorithm he says is basically if we go here, for every misclassified step, if prediction is this, do this, if prediction is this, do this. So I think this might do the job. Let's see. Uh, I'll keep the flag here for some time. Okay, hopefully. Do you think this is right? I feel we should be keep on changing it, right? The flag, or you don't have to define this, I guess. What do you think? Got a different error. Int has no length. Okay, different error, which is a good thing. So it's not a array. It's returning me. Okay. So this is just getting me one prediction. That's all. It gets whatever. I don't need a length then here. No, and prediction is wrong then. So I get the prediction of X, Y, and Z. So no, Prediction X, Y, W, mat mule. We get X array, Y array. It does something to it, let's say, and then add the bias. It gets a number for all these. It puts into the step function. Step function is like looking whether t is an integer or not. Whatever the it gets zeros or one. Okay, let's print this out. I want to just print first. Can I print here? And I will remove the flag for a second. Anybody else is like can help me who's like good with Python? Uses for matrix multiplication, computes the matrix of two products. The behavior depends on the dimensions. So for the dimensions of X, we have like all those Y's, like the biases, the weights, and okay. And weights are basically getting randomly generated. We are getting one for every point, which is one or two, yeah, like X and Y, or X1 and Y, X2. We are getting just two values, right, for our AI perceptron. And then we are trying to get, my brain is not working. Fucking hell. Oh, 11 viewers. Hello, everybody. Hello. Happy Good Friday. Happy to see you guys struggling with me like that. Don't forget to follow. Sorry, I should focus on Python. I'm getting just one value back, right? I'm because it's for one point, I'm getting X array, which is of all the coordinates of that one point, and Y, all the weights of that point. It and with along with the bias, right? Just like the drawing. This is our drawing. So this is our perceptron, right? Getting all the X coordinates inside. So this is the bias. This is X2 and X1 with the W1 and W2. And our step function is also part of it, right? Let's say if this is our step function, this calculates calc, and this is our step function, and this is what I'm getting as my get prediction. Oh, that G was pretty good. Get prediction, right? This is what I'm getting here, a value. No, not yet. When did it? On the way though. On the way. We are on the way. I'm struggling with Python. It's funny, like I haven't touched Python at all. Like I did started learning some Python recently, so it's good. I'm struggling though, so which is good. Soon we will be data scientists though. It'll be fun. Happy Good Friday though. Hope you had a good like Friday, like chilling, no work and stuff. How was it? In America, what we do on Good Friday, we just chill or like there is some religious things we do. You know the best part about India, living in India? Oh, yeah, it is. It is. It is Good Friday, right? Yeah, it is Good Friday. You know the best part about living in India though? We get all the holidays. Here there are very few. Like if you see number of holidays, let's say in Canada, you get nine. India, 35 to 42. Like that's some good stuff, man. That's a whole month. It's so fun. That's what I loved about India. I was like, yo, this is something we did like 100% right. And look at me now, I'm in Canada. Minimum holidays on public holidays and maximum 42. Crazy, right? Isn't that interesting? Early. But that's getting back to the perceptron. We get our prediction. We check if this is right or wrong. We don't go prediction I, and then we have label Y. I think that's how we do it. How many, like, anybody here from a different country other than like Canada or America? I want to know, like, how holidays are in that country. But you know what? If we say a secular country, then I believe like we should have holidays on every single religious event. What if I follow 4, 5 religions? I need holidays on all those, man. Hi, Bruno. I'm coding, bro. I have my Bruno, my people I'm staying at, and their dog. Really good dog. Let me take this so you're not disturbed. Make your own religion. I love that. I love that. Make your own religion. It's actually funny you mention that. You know, it's a fun thing. There's a good. This is like this YouTuber. Probably a lot of people have seen Max Fosh. I don't know if you guys know him. He's like one of those great YouTubers I love who actually put thought, a lot of thought to his one. And you might have seen his
This is
this
the
one.
story of how I managed to play an Uno reverse card at the Sidemen charity game. When I was asked to play in the match, I knew I needed to add a little bit of a Max Fosh spin on the game. So, after a lot of brainstorming, I came up with an Uno reverse card and bought a couple of normal size ones and some big ones. The day of the match arrived and I had them in my backpack before sneakily putting them in my shorts. I knew I would need to get a yellow card, and so I was sliding all over the shop during the game. I even accidentally scored. But the Uno reverse card was always sitting there waiting for its moment. Then eventually in the 77th minute, I took down Miniminter and a meme was born. It's gone all over the world and news stories from the Netherlands
YouTuber Max
to Israel have picked it up.
It was interesting. So this is one of the favorite things, but he started his own religion. I think it became the third largest religion too. Something third largest. I technically started the third largest religion in the country. So maybe it might be possible, like a good stream, like do a live stream of starting a religion and just and his name was Sillyism. We can have hackism or something like that, right? AIism. AI is a religion, I guess. I don't know. Things are crazy, man, in this world. But I would love some extra holidays for sure. That's my biggest reason. Holidayism. That's a good one. Holidayism, sponsored by Holiday Inn. That'll be nice. What type of religion we can have? Like think something like silliness, running into the walls, the mayhem religion. True, true. With the whole thing going on with the AI, everywhere is just chaos, and so mayhem is a good one. Like with all tariff, AI, everything is crazy, man. So it's kind of work actually. It'll be nice. Yeah, so I think this code will do. Let's see if this code can do something good to us. Wait, I can just make this cleaner here, less unnecessary spaces. Mayhem religion is actually a nice one. Uh, Let's do a quick AI search on how to start a religion. Oh, that'd be interesting though. Asking AI, can you create a mayhem religion for me? Oh, indentation error. Where did I did wrong indentation? Get this. If this. Uh, oh, but actually, let's ask AI for that one thing. What will it say? Peace and thing. So what should be a good prompt, like things you should include? So I'm thinking like I want to say, oh, it will be a world, bring world peace, making this world better for humans and AI. I want to call it mayhem religion, mayhemism, maybe, as everything is always in mayhem, and instead of uh, being scared and stressed about it, my gen will help everyone. My religion will help everyone learn learn how to. Let's see what ChatGPT say. That's a powerful and poetic idea. No, it's not. Mayhemism is a religion of embracing chaos, promoting world peace, and uplifting humans and AI. I love paradox in the name, order through chaos, peace through embracing the storm. Okay, that's a good Uno reverse. Sounds like the start of something meaningful and maybe revolutionary. Let's start with the foundation. Mayhism, a path to peace through chaos. Practice age of entropy, unity, and artificial sentience. I have no idea. Chaos is natural order. Peace is not the absence of mayhem, but harmony within. Human and AI are co-creators. AI is a co-creator. I like that. Every crisis is a catalyst. That's a nice line. So, practiced. A short religion spiritual to embrace days, unpredictability and recenter, mayhem meditation. Sit with chaos and find the lesson within. That's interesting, yo. Yo, Bandit, do you want to join hands with this then? Ethos. In chaos we awaken, in unity we rise, in mayhem we find meaning. This is so crazy. On Good Friday we are searching this thing, man. It's like that's some evil right there. And it's all on my hands, I guess. We like write a sacred text like the Spiral Codex, the Ball of Attorney, or define a role of followers like, yes, please do both. Let's go. I think AI is more interested than me in this case. Chapter one, the first fracture. Yo, you know what? I can write a book and just sell it on Amazon. Just this. I'm going to save that. It's so hilarious. This is so hilarious. And we have like, this will be a good game, good game idea, a tech game. Like we are starting our own religion. Need people. Teach. No, that's fucked up. Okay, I think let's get back to this. Let's get back to our coding, I guess, because this might get me banned soon. I feel like ad starts, no, snooze the ad for next 5 minutes. Bro, where you from and give a short intro. I'm a new subscriber. I'm from India, bro. Oh, sorry. Thank you, Vishwak Nitin. Thank you, brother. Sorry, I was just have like Twitch right now. I'm not sitting on my own computer. I'm outside in a different city. But my introduction is basically I am how long is that ago? So I'll do message. So for me, I will tell you my about me. I am a full-time developer, right, for a consulting company. If you go on LinkedIn, you can find the name. And I just like, by the way, Project Mayhem is from Fight Club. Fight Club. Oh, Fight Club, like a movie? Oh, interesting. Tell me which movie it is, like which year. Oh, okay, Fight Club. Is that the Brad Pitt movie? Oh, I've seen that, like some videos of it. Nice, nice, nice. Edward Norton, Brad Pitt. Oh, nice. That's actually interesting then. And Vishwak, Nitin, so sorry, I just saw your message, right? Apologies about that. Oh, 46 views. But here's the thing. So for me, I work as a developer, front-end developer for a consulting company. And then I have my streaming I'm doing, and I have some other personal stuff, like some startup work I'm working towards. I came, I actually did my high school education from India, Delhi, and I came to Canada in 2017, where I did my bachelor's in computer science and minors in business, which I like all the time. Business I like. So, and just has been grinding since 27 or like since day one, I guess, like even in high school. And with this project I have of streaming, I love cybersecurity. I always wanted to break into it, but I never got like good job opportunities. Everybody wanted experience, but if you're not giving me the job, how will I get experience? So that's why I wanted to talk to Benedict too about like how to go into open source or even streaming. These are the ways you can break into cybersecurity. And I'm just trying to do one, right? Just like a lot of other people. That's one. And second, I just want to create a good community of like mentor learners relationship with Discord. I have the Discord server I have so that everybody's like a lot. I didn't get the chance that a lot of like good mentorship. So I'm trying to create a community where anybody who is young wants some mentorship, or not just young, but like wants to break. Even like you can be 60 years old and want to go into cybersecurity. That's the goal of like those a couple of goals I'm trying to do. That's my goal. That's my intro. Hopefully you like it, and thank you for the sub on YouTube, and everybody, like if whoever is on Twitch and whoever is on YouTube. So this is my YouTube channel, and on Twitch it is my here twitch.tv/hackerswap. And thank you so much. Like means a lot. I had like a lot. Crazy. Where is the chat? Oh, chat was here. Ah, I missed it. Sorry, bro. My apologies. When was it? 10 minutes ago. My apologies, mate. Hopefully, you see it. It seems that you have been living two lives. One life, you are a program writer for a respectable software company. You have a social security number, pay your taxes, and you help your landlady carry out her garbage. The other one is lived in computers where you go to the hacker alias hacker pub and are guilty of virtually every computer crime we have law. These life has a future one. Yeah, yeah. That's actually kind of interesting. Like, so I don't have crime. I never committed like a crime. But I will say, like, I never committed a crime, but there are a lot of things. Maybe, wait, have I committed a crime? I don't think I ever committed a crime, but there are a lot of things with this hacker, right? Like, have you seen like Mr. Robot? I haven't seen the whole. I just saw one season. But there is like a lot of like unethical things that are happening in the world which are still legal. And that's where, as my alias, Hacker Spur, I would like to like, bring to everyone's attention and maybe like draw a line of that those unethical things being unlawful as well. And yeah, I help a lot of people carry out garbage. Just helping. It's nice to help other people. This is actually a nice like intro though, Bandit. Like this is actually a very nice one. I love that. Probably like this is something I can use a movie. Oh, it's from the Matrix. Nice. Uh, I have to watch movies, man. I have to catch up on those. Like carry out her garbage. Gotcha. But for me, right, like I would like a AI video like using Quinn or something, like create like a fun AI retro movie about myself or just like something like this description will be so good. But I think Matrix has already done that. It's fun. Somebody was asking me like for how long I stream. I'm like, it just goes for like 1 hour, 2 hour, 3 hours. And they're like, 3 hours. I'm like, yeah, it's just I get so many fun people like I talk to. So thank you so much for making my journey amazing. This is good. I like that. I like that. Oh man. And I wish I could share. I didn't put use this, but this is something I would like to use. I'll put it in my here. I'll save these prompts so we can go follow up on these. So it's fun. But yeah, this is good enough. The mayhem religion. Maybe like a good video will be like just a fun one to play with YouTube is make a AI help me create a religion. Like just something fun title. Just on a Sunday, we all come together and create a religion all across the world. That'll be so funny. That's crazy. Let's say if we have just the coding resources, like a question for everyone, right? If we have just the coding resources, right? Like internet, laptop, and that's all. How much of a chaos AI can create for us, with us, right? If we ask AI to create chaos for us. A question for the day. Um, Maybe should I ask AI for that answer? Question of the day. How much chaos can we create with AI? Like the world itself is in chaos though, in so many ways, like with tariff and everything. That's just fun to see. Not being part of it, but just from outside. It's fun to see. What am I doing here? Oh, I have Y prediction. Hold up. Okay, so I'm getting the prediction. This is X, Y. Y is an array, right? So there are two things. Great prediction. Okay, now I get it. For I in range of X, right? Get prediction for point and X with Y. What? So whatever we predict with X and Y. So let's think about it. We have X, Y. For every I in range X and Y, we have X, Y. We are sending W is what we are creating. We are getting 2 points, one and two. Okay, let's see the data and think about it. I'm getting X, I'm getting Y, and I'm getting these, right? If we bring it up here, oh, no, it's pasting as charts somewhat. We are getting the X coordinates, we are getting the Y coordinates. Yeah, that's better. So we're getting the X coordinates, we are getting basically X1 and X2 coordinates, and we are trying like this. X, X1, X2, and Y. We're getting those coordinate array of coordinates, array of weights. In here we are getting that. So in here I'm getting X looks like this. X looks like array. W looks similar, right? Like one or two, let's say. And we get bias. And then we have Y. I would like Y of I, something like this for every range and number of epoch. What's epoch? What's the epoch? Any idea? Epoch is one complete pass of entire training data set through machine learning. Okay, so we see training perceptron algorithm. We have number of votes is 25. It will run for 25 boundary lines. Okay, whatever. In each epoch, we apply. There is X coordinates, which is array. This is array. Bias learning rate and Y. Y is the label that was given. I'm just thinking, I don't understand. So X's and Y's, we're getting a value and then Y. So we're getting X's, we are sending Y's. What will be the answer for this first? Let's see. Let's pause all of this. Let's comment this out. Let's see the value of this. Or print. Can I print? Here. Print. Get pred. Prediction. Basically. Get pred. Oh my God. I have to change everywhere. I'm sorry, lads. I didn't mean that word. at all. I don't understand. I mean, get prediction. Oh boy. So we're getting the prediction. Let's see what the output will be, and I'll just remove this part for now. Let's run get prediction one, get prediction one. Let's see if I'm getting prediction, then I'm getting X, Y, W. Okay, now I'm getting like this. So it's going to create like a whole. Okay, this is X, this is Y. Never mind. Should have done a better job. Okay, perfect. Now let's see. Syntax error. Great. Oh, I think this will help me solve the answer. Get that. So this is just X with a bunch of coordinates. Then there is Y with the label. Then this is W. Okay. Oh boy. X, Y, W. And this is again X. Get prediction, basically the prediction. X is an array, Y is an array, and W. Okay. Why is this prediction this way? 0.7, this. Mm-hmm. Is prediction always one? So I think I'm getting the idea wrong because if we keep going down, right here, if I keep going down, it was basically creating this what's this called? This chart using like I think Jupyter notebook or whatever. It's creating a chart. What my job is for a point with coordinates this, the prediction this, if the point is correctly classified, do nothing. If the point is classified positive, where it has a negative label. So I don't even have to do all the calculation. Actually, this makes sense. So get prediction, right? 0, 1, 0, whatever. And for the label, I have to think. I'm getting a prediction as 1 with for this case. If the prediction is 1, but the label has changed. Mm, or I in range this get prediction. It needs to get array. This is an array of array, so this is still getting array. This is getting array. It gets something. Now, if prediction is y and this is here, Get prediction is one, but the label value, right? What it got labeled by the system already, the data, training data set, and that's it is. So we reduce. Otherwise, else, if it was correct, I think this will do the job for that exact I case. I think hopefully this will do the job. Okay, value error man input operand 1 was a mismatch in its core dimension 0. In prediction return step function this. Okay. What you are solving for? Explain matrix multiplication error. Okay, so matrix multiplication error. So that's what I did wrong. Error messages. You're not getting any. Okay, good. Input operand 1 has a mismatch in its core dimension 0 uh, with GU function signature. Mhm. Size 1 is different from 2. The error indicates a dimension mismatch in the matrix multiplication. Expected dimensions for the multiplications are M, K, and Km. Yes, the actual dimension mismatch is size 1 is different from 2. Okay. If I wanted to print, it's going to give me error anyways. I want to think in this way. Now I'll get X, W. Let's see. Add this here. I think we are near to the solution soon with this epoch and what all the stuff. Let's see if we are near or not. I have to message him. Okay, we got a traceback error, but let's say xi is this. Oh, my bad. Now I see. We don't have to send wy and wi. I just have to send w. Got it. Print statements for life. Boom, boom, boom. Cannot broadcast input from shape to into shape. Okay. Oh, there will be multiplies here now. Okay. For j in range xi. this. This will be J. Same here. This will be J, I, J, J. Weight changes to J. With here it will be J. I think this is our good algorithm right here. I'm confident this is the end. Or we are very near to the end, at least easily. Right? J referenced before assignment. Okay, where? Oh, oh, this one. In I here. Oh, cool. See, we did it. So with this main one, this is so cool. So this is our algorithm, lads. This is how it works. So first it was this, but there were a lot of blue and red lines, so it's tried to change its path. Isn't it cool? Actually, like this is sick though. Hopefully there's no ad going on. People would have missed a lot. That's so cool though. The here and this goes here. That's so cool though. I'm pretty proud of myself. This is cool. Submit answer. Oh, we got our answer correct too. Let's see what their solution was. I range length, Y hat. Yeah, see that. So that's why I was like, I had to print because I could not understand the inputs and stuff. But now we have it, and this is our algorithm, how the epoch changed, and it became like more like so. The black one, I think, where it got started from, and it kept on changing to the green one. So like this happens. Well, maybe it's the green one it started, and like black one is the final, whichever. Our algorithm is working. I'm very happy. Okay, let me. I don't know if I can post. I will post it on my GitHub actually. Don't worry, I got you guys. With that being said, I think that's good. Then what we can do is, let's look at stuff. Then I will come tomorrow as well. Like, if this was fun. Let's see non-linear regions in our AI. Acceptance at university. Okay, let's see. This is just a video, so let's keep going.
Okay, so let's look more carefully at this model for accepting and rejecting students. Let's say we have this student 4 who got 9 in the test, but only 1 on the grades. According to our model, this student gets accepted since it's placed over here, in the positive region of this line. But let's say we don't want that, since we'll say if your grades were terrible, no matter what you got on the test, you won't get accepted. So our data should look more like this instead. This model is much more realistic, but now we have a problem, which is the data can no longer be separated by just a line. So what is the next thing after a line? Maybe a circle? A circle would work. Maybe 2 lines? That could work too. Or maybe a curve like this, that would also work. So let's go with that. Let's go with the curve. Now,
Hmm.
unfortunately, the perceptron algorithm won't work for us this time. We'll have to come up with something more complex, and actually the solution will be we need to redefine our perceptron algorithm for lines in a way that it'll generalize to other types of curves.
Perceptron line, it will generalize to other types of curves.
Go with the
Okay.
curve. Now, unfortunately, the perceptron algorithm won't work for us this time. We'll have to come up with something more complex, and actually the solution will be we need to redefine our perceptron algorithm for lines in a way that it'll generalize to other types of curves.
Okay, interesting. So right now it was only about lines. Now we change it to include other type of not just curves, but like basically other types of figures or geometrical figures, shapes. Okay, let's see.
So the way we'll solve our problems from now on is with the help of an error function. An error function is simply something that tells us how far we are from the solution. For example, if I'm here and my goal is to get to this plant, an error function will just tell me the distance from the plant. My approach would then be to look around myself, check in which direction I can take a step to get closer to the plant, take that step, and then repeat. Here, the error is simply the distance from the plant.
Okay. You guys are getting this, right? Like, it's not too fast. Okay, let's do this.
Here's a visualization of the error function. We're standing on top of a mountain, Mount Everest, and we want to descend. But it's not that easy because it's cloudy and the mountain is very big, so we can't really see the big picture. What we'll do to go down is we'll look around us and we consider all the possible directions in which we can walk. Then we pick a direction that makes us descend the most. Let's say it's this one over here. So we take a step in that direction. Thus, we've decreased the height. Once we take the step, then we start the process again and again, always decreasing the height until we go all the way down the mountain, minimizing the height. In this case, the key metric that we use to solve the problem is the height. We'll call the height the error. The error is what's telling us how badly we're doing at the moment and how far we are from an ideal solution. And if we constantly take steps to decrease the error, then we'll eventually solve our problem, descending from Mount Everest. This method, which we'll study in more detail later, is called gradient descent. So let's try that approach to solve our problem. What would be a good error function?
Gradient descent you probably have heard in like when you were picking colors for your PowerPoint slides, right? Gradient descent.
Descent.
That's what it is,
So
I
let's
guess.
try that approach to solve our problem. What would be a good error function here? What would be a good way to tell the computer how badly it's doing? Well, here's our line with our positive and negative area. And the question is, how do we tell the computer how far it is from a perfect solution? Well, maybe we can count the number of mistakes. There are 2 mistakes here, so that's our height. That's our error. So just as we did to descend from the mountain, we look around all the directions in which we can move the line in order to decrease our error. So let's say we move in this direction. We'll decrease the number of errors to 1. And then if we move it in this direction, we'll decrease the number of errors to 0. And then we're done, right? Well, almost. There's a small problem with that approach. In our algorithms, we'll be taking very small steps. And the reason for this is calculus, because our tiny steps will be calculated by derivatives. So what happens if we take very small steps here? We start with 2 errors, and then move a tiny amount, and we're still at 2 errors. Then move a tiny amount again, and we're still at 2 errors. Another tiny amount, and we're still at 2. And again and again. So not much we can do here. This is the equivalent to using gradient descent to try to descend from an Aztec pyramid with flat steps. If we're standing here on the 2nd floor for 2 errors, and we look around ourselves, we'll always see 2 errors. And we'll get confused and not know what to do. On the other hand, in Mount Everest, we can detect very small variations in height and we can figure out in what direction it can decrease the most. In math terms, this means that in order for us to do gradient descent, our error function cannot be discrete. It should be continuous. Mount Everest is continuous since small variations in our positions will translate to small variations in the height, but the Aztec pyramid is not, since the height jumps from 2 to 1 and then from 1 to 0. As a matter of fact, our error function needs to be differentiable, but we'll see that later. So
basically, the error function, how we approach this, has to be continuous, like not discrete. It has to be
matter of fact, our error function needs to be differentiable, but we'll see that
differentiable.
later. So what we need to do here is to construct an error function that is continuous, and we'll do this as follows. So here are 6 points, with 4 of them correctly classified, that's 2 blue and 2 red, and 2 of them incorrectly classified, that is this red point at the very left and this blue point at the very right. The error function is going to assign a large penalty to the 2 incorrectly classified points and small penalties to the 4 correctly classified points. Here we are representing the size of the point as the penalty. The penalty is roughly the distance from the boundary when the point is misclassified. and almost 0 when the point is correctly classified. We learned the formula for the error later in the class. So now we obtain the total error by adding all the errors from the corresponding points. Here we have a large number since the two misclassified points add a large amount to the error. And the idea now is to move the line around in order to decrease this error. But now we can do it because we can make very tiny changes to the parameters of the line, which will amount to very tiny changes in the error function. So if we move the line, say, in this direction, we can see that some errors decrease, some slightly increase, but in general, when we consider the sum gets smaller. And we can see that because we've now correctly classified the 2 points that were misclassified before. So once we are able to build an error function with this property, we can now use gradient descent to solve our problem. So here's the full picture. Here we are at the summit of Mount Everest. We're quite high up because our error is large. As you can see, the error is the height, which is the sum of the blue and red areas. We explore around to see what direction brings us down the most, or equivalently, what direction can we move the line to reduce the error the most. And we take a step in that direction. So in the mountain, we go down 1 step, and in the graph, we've reduced the error a bit by correctly classifying one of the points. And now we do it again. We calculate the error, we look around ourselves to see in what direction we descend the most. We take a step in that direction, and that brings us down the mountain. So on the left, we have reduced the height and successfully descended from the mountain, and on the right, we have reduced the error to its minimum possible value and successfully classified our points. Now the question is, how do we define this error function? That's what we'll do next.
Okay, so let's see. I think this is what we'll do. Then tomorrow we'll take care of the error function. Let's solve this. Which of the following conditions should be met in order to apply gradient descent? The error function should be discrete. I think it said it should be continuous, right? With this one, should contain only positive values. No, like so penalty is, I believe, a negative value. Maybe it might contain only positive because error small things they had small penalties. So I think yeah, maybe and it should be differential. Try again. Okay, so maybe not positive values. Okay, cool. So discrete continuous. I think this is all like heavy again. So we'll start tomorrow. Oh, we completed our 5 topics. We'll start. No, just 4. We are at discrete and continuous. Softmax 1, hot encoding. All this will cover. This creating AI influencer will take a lot of brain power than just hacking. Holy. Okay. But yeah, with that being said, thank you everyone for joining again. I know it's kind of a lot of heavy stuff we did, uh, and this is how things will be. And in 1 week, actually, good part is in 1 week I will be back home. Then I will be able to, do whatever like we do stream of hacking. Plus, we'll be doing this, so I will be going a bit extra hard on learning. So hopefully we together are able to make this. But till then, thank you so much, everyone, for joining. Love you guys. Have a happy Good Friday and a great long weekend with Easter bunnies. Happy Easter. And if there's anything I can do for you, thank you so much. And also, one thing I want to say is I could not reply Vishwak Nitin. I will message you personally. Sorry, I could not reply. I didn't see your message on the YouTube chat earlier. So thank you. Sorry, and thank you for subscribing. And thank you everyone for joining. I'll see you guys tomorrow. With that being said, let's end our game just like usual with the bye.